So in this lecture, we'll define what a tree is, its characteristic structure, important terms relating to tree ADT, and some general uses of tree ADT. The first question is, what is a tree ADT? You are already familiar with arrays, then stacks, queues, and linked lists. All these were linear data types. Now we are going to introduce you to the first of the non-linear data type called the tree data type. So it is a non-linear data structure with relationship other than the adjacency. Adjacency is one next to the other, as in arrays and linked list, etc., or queues. Here we have a relationship called the parent, children, and siblings are present. Let us come to the general definition of a general tree, mathematical definition. A tree is a finite set of one or more nodes. These nodes have some data value, data items in that, such that there is specifically designated node called the root. Root is on top, and remaining nodes are partitioned into n greater than equal to 0. If it is 0, only there is a root. If there is more than 0, there are going to be what are called the children and the siblings. So is a 0 disjoint set of t1, t2, etc. up to tn, where each of these sets is a tree. So we have got the root, and we will have the sub trees. We call sub trees on right and left of the main root. So this is the mathematical definition. So let us understand. So this is the root only. There is only one root in the tree. Now it may have more subtrees. There is here in this picture I have shown you three subtrees. There is one subtree here, this one subtree here, one subtree here, and each has got the parent and children, etc. So this is the structure of a tree, general tree. But we are very much interested in binary tree, which we will come into. As I see again, this is the root. This is called the edge of branch. This is called the parent of the subtree. This is all the parent of the subtree. But this is the child node of this parent root. This is all the child node of this root. And here again this is the child node of this parent. These are end nodes, are called leaf nodes. These are called siblings. They are at the same level, and these also happen to be the leaf nodes. And this is also a subtree. This is also a subtree. This is also a subtree. So this is how trees are arranged. Let us come to some of the important terms relating to tree data structure. Path. Path refers to the sequence of nodes along the edges of a tree. Root, as I gave you already, is the top of the tree is called the root. There is only one root per tree and one path from the root node to any other node. Parent. Any node except the root node has one edge upwards to a node called the parent. So from parent you have got the child nodes, maybe two or more of that. Of course, when we deal with binary tree, there will be only two children. So this is child node below a given node connected by its edge downward is called the child node. From parent you get the child node. Leaf node, which does not have any child node, is called the leaf node. Subtree, as I've explained, subtrees represent the descendants of a node. The root is there, it has got subtree. Even this subtree has nodes. That node will have subtrees, etc. Visiting. Visiting refers to checking the values of a node when control is on the node. Traversing, we would continuously like to traverse a given tree. There are different kinds of traversing. We will deal with those, and we will also program that. So traversing means passing through nodes in a specific order. For example, it's called the pre-order, in-order, post-order, etc. Levels. Levels of a node represents the generation of a node. If the root node is at level 0, then its next child node will be at level 1, its grandchild is at level 2, etc. It goes on. So level 0, 1, 2, 3, etc. Keys represent a value on a particular node. So these are the keys. These are some terms which we will be using as we learn. Again, coming back to this is a binary search tree. As you see, binary means there is root has only two children. Every node has two children. We will be dealing mostly with the binary tree, binary called BST, called binary search tree. So we have got the root here. These are the two children here. This is the subtree here. This is one more subtree. This is the parent node of this. This is the parent node of D and E. This is the parent node of these two child nodes, and these are called the leaf nodes. End, they don't have any children. End nodes are called the leaf nodes. And I mentioned also level. So root node is at level 0, and its children are at level 1, grandchildren are at level 2, etc. It goes on. So levels are this is called, also called the height of the tree. For example, take this. So here is an example of a binary search tree. As you see, that contains data items, numbers. As you see, a 5, 10, 12, etc. Now this is level 0. Is the level 0 contains only one data item. So we represent therefore 2 to the power h. H represents the level. So 2 to the power 0, therefore 1. Here level 1 contains two nodes. Because 2 to the power 1 is equal to 2. Level here 0, 1, 2, level 2 contains 2 to the power 2, therefore 4 nodes. And level 3 contains 2 to the power 3, 8 nodes. It goes on like that. So you can have a formula called 2 to the power h. H represents the level, maybe 0, 1, 2. Immediately you can calculate the maximum number of nodes which could be present at each of these levels. So please remember that. So some of the basic operations, there are some simple operations called insert. When we want to create a binary search tree, we would like to insert data items or nodes onto the thing. That is called inserting, is called an element. Inserts an element in a tree. These are some of the operations. Every ADT has some operations. So these are the operations. As in the case of Q, we have NQ, DQ, etc. So here insert is the name of the operation. Searching could be different kinds of searching. So searching an element in a tree. Then traversals. So it's called the pre-order traversal. There is called the in-order traversal, and this is called the post-order traversal. In-order traversal gives us the data items in the ascending order. So these are the three important traversal methods. We will be dealing with them, and we will be also programming those traversals. With that, we come to the final section of this lecture, uses of the tree data type. Tree data type is used in explaining relationships between data items. It is used in data storage. It is used for searching data items. We want to arrange the data items in the tree structure and then search the data items. It's a much better searching method than we have done earlier, called linear data search. So in operating systems, it is used in operating systems. It is used in graphics. It is used in database systems and in computer networking and in compilers. These are some of the uses. We are not going to deal with them in depth, but just know that tree data structure is used in some of these things. And in filing system, we are using all the time filing system in computers, so it is used in filing system. So for example, one simple HTML here, you have got file is there. So a tree corresponding to markup elements in a web page. So here head is there, HTML, first is HTML. HTML has head and body. As you see, head and body. This head contains meta and then title, etc. This body can contain UL here, then H2 header 2 and H1 header 1, etc. So all these are, and the UL contains is a list, list 1, list 2, etc. So this is the representation of an HTML page. So this gives an idea how tree data type could be used for various uses.